Welcome to 3.2 Equilateral and Isosceles triangles. We're going to start with the definition. You know it, but we need to go over some parts of the isosceles triangle. Isosceles triangle has two congruent sides. The two congruent sides are called legs. They create a vertex angle. The third side is called the base. The other two angles are called the base angles. So here's our image. You have the congruent legs creating the vertex angle. You have the base, which just so happens to be on the bottom in this example, and the two angles touching the base are called base angles. So the isosceles triangle theorem states if two sides are congruent on a triangle, then the angles opposite those sides are congruent. So in other words, the base angles are congruent. So our base angles in the first example are 50 degrees, therefore x is 50. In our second example, the base angles are 74, and if we add up our angles, the vertex angle x plus our base angle 74 plus 74, it equals 180. So what we're doing is we're subtracting 180 from our base angles. 74 twice is 148. 180 minus 148 is 32 degrees. So our vertex angle in this example is 32. The converse of the isosceles triangle theorem states that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. In other words, the legs are congruent if the base angles are congruent. So our legs in the first example is both 6, so x is 6. Our legs in the second example are both 7, so x plus 17 equals 7, therefore x is negative 10. There's a couple of corollaries to the isosceles triangle theorem, and those are actually having to do with the equilateral triangle. So an equilateral is a special type of isosceles triangle where all sides are congruent. And it states that if a triangle is equilateral, then the triangle is equiangular, meaning all angles are 60, because 180 divided by 3. So in our first example, x is just 60. In our second example, we set 4x plus 16 equal to 60. Subtract 16, divide by 4, and we get x is 11. The converse to this corollary, so it's a different corollary, is that if a triangle is equiangular, then it's equilateral, meaning all sides are congruent if all angles are congruent. So our first example, x is just 7. Our second example, we set x plus 18 equal to 11. Subtract 18 and we get x is negative 7. Our final theorem is that if a line bisects the vertex, meaning it's an angle bisector, of an isosceles triangle, then the line is also a perpendicular bisector. So in other words, if it's isosceles, meaning two congruent sides, and the vertex angle is being bisected, then the base would therefore be bisected and perpendicular, 90-degree angle. Okay. So that's everything there is to the isosceles and equilateral. Good luck on the practice.